The James Webb Space Telescope, JWST, represents a monumental achievement in space exploration, one that has been decades in the making. For over 25 years, dedicated scientists, engineers, and visionaries have worked tirelessly to bring this project to fruition. As the old adage goes, the journey required more than a little bit of luck. It needed a series of miracles to make it a reality. One of the most inspiring figures in this journey has been Bill Nye, the beloved science guy, whose passion for the cosmos has sparked a sense of wonder in millions of people worldwide. Through his engaging approach, Bill has made the vastness of space feel just a little more approachable, inspiring curiosity and awe. Now, thanks to the incredible advancements of the James Webb Space Telescope, the cosmos is no longer just a distant curiosity. It is something we can see with astonishing clarity. With Webb's remarkable precision, we are now able to capture images of far-off cosmic objects that were once beyond our wildest imaginations. Some of these images date back over 13 billion years, allowing us to peer into the early universe, all while igniting Bill Nye's palpable excitement. Today, we embark on a journey through these amazing discoveries and explore how they are reshaping our understanding of space, time, and even life itself. The potential to revolutionize our understanding of the universe. The James Webb Space Telescope is already being hailed as a groundbreaking successor to the Hubble Space Telescope. Webb promises not only to surpass Hubble's capabilities, but to explore areas of the universe that no other telescope has ventured before. A key element in Webb's success is its enormous primary mirror, which is 7 times larger than Hubble's, allowing it to capture more light and provide greater clarity in its observations. This means that Webb can peer further into space and gather data from objects that were once too faint or too distant for previous instruments to observe. Webb's advanced instruments have opened up new possibilities for studying some of the most mysterious phenomena in the universe, from distant galaxies to exoplanets. For Bill Nye, the excitement lies in how these discoveries are providing profound new insights into the very nature of the universe, and potentially life itself. As we explore Webb's discoveries, we see how the telescope is changing the way we view everything from star formation to the origins of life in the cosmos. The creation of the James Webb Space Telescope. The development of the James Webb Space Telescope was no small feat. It was the product of decades of collaboration among NASA scientists, engineers, and international partners. After years of meticulous planning and construction, Webb was launched on Christmas Day 2021. A momentous occasion marking the beginning of a new era in space exploration. However, the telescope's journey was far from simple. Its deployment required a series of incredibly precise steps to unfold and position its solar panels, mirrors, and instruments. The process was a painstaking one, requiring months of careful adjustments and testing to ensure everything functioned as intended. By June 2022, Webb became fully operational, and the world was treated to some of the most awe-inspiring images of deep space ever captured. Almost immediately after activation, the telescope began to make groundbreaking discoveries. Within days, astronomers using Webb's instruments uncovered thousands of new galaxies, some of which were more than 150 million years older than those detected by Hubble. Webb's unprecedented sensitivity to infrared light allowed scientists to study distant galaxies and stars in ways that were previously impossible. Its ability to detect light from objects like exoplanets and developing stars also opened the door to studying the composition, motion, and chemical makeup of objects across space. Bill Nye enthusiastically points out that the telescope has already begun to reveal the atmospheric conditions of planets that are hundreds of light-years away, raising tantalizing possibilities about their potential to support life. Webb's insights into the pillars of creation. One of the most iconic images captured by the Hubble Space Telescope was of the Eagle Nebula, known as the Pillars of Creation. These towering columns of gas and dust are the birthplaces of stars, and they have captivated astronomers and the public for years. However, while Hubble's optical images gave us a beautiful view of the structure of these clouds, they could not show the actual process of star formation within them. This is where the James Webb Space Telescope truly shines. Using its infrared capabilities, Webb was able to penetrate the gas and dust clouds surrounding the pillars of creation, revealing what lies beneath the surface. Webb's images show protostar clusters, massive clouds of gas and dust many times the size of our solar system, where new stars are being born. These protostars are still in the early stages of their development, and while they are not yet fusing hydrogen, they are on the brink of doing so. Bill Nye explains that as these stars continue to pull in more material, they become denser, eventually reaching a point where hydrogen fusion occurs, igniting the star and causing it to heat up to millions of degrees. The colors in Webb's image are not just artistic choices but represent different infrared wavelengths, with red portions indicating the hottest areas, such as the forming protostars. This image not only showcases Webb's incredible infrared capabilities but also offers a glimpse into the very processes that create stars like our Sun. The search for exoplanets. The quest to find planets outside our solar system, known as exoplanets, has been one of the most exciting frontiers in modern astronomy. Since the discovery of the first exoplanets in the 1990s, over 3,000 exoplanets have been catalogued. However, detecting these planets is not easy. Due to their immense distance and the blinding light of their parent stars, exoplanets are incredibly difficult to observe directly. Most exoplanets are detected indirectly through methods like the transit method, which measures the slight dimming of a star's light as a planet passes in front of it. The James Webb Space Telescope has changed the game. In September 2022, Webb made history by capturing its first direct image of an exoplanet, HIP 65426b, a massive gas giant discovered in 2017. Webb used its coronagraphs, special instruments designed to block out the light from the host star, allowing the planet itself to be visible. The telescope's advanced infrared cameras and filters provided an incredibly detailed image of this distant world, showing its characteristics with remarkable clarity. HIP 65426b is an enormous planet, nearly 12 times the size of Jupiter, and it orbits its star at an extraordinary distance, about 100 times farther than Earth is from the Sun. This separation made it an ideal target for direct imaging. But capturing the image of this exoplanet is just the beginning. Webb's capabilities allow it to study not just the planet's size and location but also its atmosphere and composition. With the ability to analyze the atmospheres of exoplanets, Webb could soon provide us with information about the chemical makeup of these distant worlds, potentially even revealing clues about their habitability. This opens the door to the possibility of discovering planets in the habitable zone of their stars, where conditions might be right for life to exist. The Phantom Galaxy. A deep dive into M74. One of the most striking discoveries made by Webb is its detailed observation of the Phantom Galaxy, also known as M74. This spiral galaxy has long been admired for its exquisite structure, which was first captured by Hubble in optical images. However, Webb's infrared images have revealed a completely new side of M74, showing intricate patterns of gas and dust stretching from its central core like luminous fibers. These threads of glowing gas are seen in vivid electric blue, offering a striking contrast to Hubble's optical images. Webb's ability to capture light at longer wavelengths has allowed scientists to peer deeper into M74's star-forming regions, revealing crucial information about the processes governing star formation. These observations help astronomers understand the composition of interstellar dust and gas, as well as the mechanics of star formation in distant galaxies. Researchers have combined data from both Webb and Hubble to create stunning composite images that provide a more comprehensive view of M74's structure. The combination of Hubble's optical clarity and Webb's infrared precision represents a major leap forward in our understanding of distant galaxies and the forces at work within them. Mysteries of Wolf-Rayet stars. The James Webb Space Telescope has also turned its attention to some of the most intriguing and rare stars in the universe, Wolf-Rayet stars. These massive, evolved stars have already shed much of their outer hydrogen layers, releasing vast amounts of gas and dust into space. Webb's imaging capabilities captured a stunning view of WR-140, a Wolf-Rayet star located far from Earth. The image revealed concentric rings of gas and dust surrounding the star, each one formed by the interaction between WR-140 and its companion star. These rings, which appear slightly boxy instead of perfectly circular, suggest a more complex interaction between the two stars. This discovery is particularly significant because it challenges previous assumptions about how such interactions occur. Webb's powerful equipment allowed astronomers to study these patterns in extraordinary detail, providing new insights into the behavior of these massive stars and their impact on the surrounding space. Reaching the farthest galaxies. One of Webb's most ambitious goals is to peer back in time to the earliest stages of the universe, when the first galaxies began to form. By December 2022, Webb had already made a major breakthrough in this area, revealing 4 of the most distant galaxies ever observed. These galaxies, seen as they were 13.4 billion years ago, existed